Okay, so we're starting our new topic of further functions and graphs today, and we're starting off with looking at our hyperbola. Now, we looked at our hyperbola last year, and we're just focusing on the graph of the function y equals k on x, where k is a constant, is our general formula for our hyperbola. So what we're going to do to start off with is we're going to sketch the graph of y equals 1 on x, and we're going to find the function's domain and range. So how we can sketch and graph a parabola is by doing a table of values. Okay, so what we want to do is we replace our x in our function with our x values. So the first one will be 1 over negative 3. We just get negative a third for that. 1 over negative 2 is negative a half. 1 over negative 1 is negative 1. 1 over negative a half is negative 2. 1 over negative a quarter is negative 4. Now, when I put 1 over 0 into my calculator, I'm going to get a math error because we cannot have 0 as a denominator. So we're going to have a 0 there. Then when I put 1 over a quarter, I get 4. 1 over a half, I get 2. 1 over 1 is 1. And 1 over 2 is a half. 1 over 3 is a third. Okay, what do we notice? We notice that the function does not exist. Oh, we don't want to put 0 there, sorry. We want to put an x because it doesn't exist there. Okay, the function doesn't exist at x equals 0. So our line x equals 0 is our vertical asymptote. We then have a horizontal asymptote is also at y equals 0. Okay, so our function does not exist on our axes here. From here, we can just plot our points. So at a half, we're at 2. At 1, we're at 1. At 2, we're at a half. At 3, we're at a third. So we just generally need, the general shape of our function and some key points. What is going on? Okay, and our general shape of our parabola going through those points is a nice curve in our first quadrant. Okay, what we want to do is we want to put arrows at either end. We also want to pick a point and label it. So the easiest point to label is 1, 1. Now I'm going to look at my negative x values, and for my negative x values, I have at negative 2, it's at negative a half, at negative 1, it's at negative 1, and at negative a half, it's at negative 2. They're probably my 3 key values that I need to help me draw my hyperbola in this quadrant, like so. Okay, it wants to be a nice smooth curve. We then want to pick a point, which in this case, the easiest one to pick is negative 1, negative 1. Okay, the last thing that I need to do on my graph is I need to write my function somewhere near my graph, so y equals 1 on x. Now, that I've sketched it, the second part of my question is asking me what the function's domain and range is. So just a reminder, domain is all the x values it can be, range is all the y values it can be. So our domain is from negative infinity to 0 and 0 to infinity. Okay, we can't just write that it's negative infinity to infinity because it doesn't exist at 0, and that's why we've got the curved bracket at 0. Now, our range is actually the exact same, negative infinity to 0 and 0 to infinity. This is because we haven't transformed our graph anywhere. As we move our hyperbola around our Cartesian plane, the domain and range will change. Okay, hopefully we've all got that copied down. What we're going to do is we're going to have a go at example 2. So with example 2, we now want to sketch the graph of y equals negative 2 on x. So we're going to use our table of value to do this. So negative 2 over negative 3 is 2/3. Negative 2 over negative 2 is 1. Negative 2 over negative 1 is 2. Negative 2 over negative a half is 4. And negative 2 over negative a quarter is 8. Okay, x can't be 0, okay, because we can't have a 0 on our denominator. So we put an x there because it doesn't exist, telling us that that's where our asymptote lies. We then have that x equals a quarter, so negative 2 over a quarter is negative 8. We have a negative 2 over a half is negative 4. Negative 2 over 1 is negative 2. Negative 2 over 2 is negative 1. And negative 2 over 3 is negative 2/3. Okay, our asymptotes have not moved. Our asymptotes are still at our x equals 0 and our y equals 0. So that's where our function does not exist. So if you want, you could write down that the asymptotes are at x equals 0 and y equals 0. Jaden, this is your time to be listening and learning, not talking. Okay, we can then sketch this graph by plotting a few key points. Now, what we have in the second one compared to the first one is that for our negative x values, we have positive y values. So that means for that, we're going to be chilling in our second quadrant. So what we will have is at negative 2, we're at 1. At negative 1, we're at 2. At negative a half, we're at 4. Okay, so we're over in our second quadrant, like so. And we want to pick one of these points. Now, these points are a little bit nicer. I'm going to choose the point negative 2, 1, okay, to put my coordinate and label the point on. But you could pick negative 1, 2 if you'd like. Now, our positive x values have negative y values. So that means we're down in our fourth quadrant. So what we're going to do is plot those points. So at a half, we're at negative 4. At 1, we're at negative 2. At 2, we are at negative 1. They're probably 3 key points that we need to get the general shape of our curve. Okay, it doesn't really matter what is happening as long as we get those 3 key points. All the ones that have our fractions are a little bit hard to do. I'm then going to pick a key point. This time I'm going to pick my 2, negative 1. But you could pick 1, negative 2. All right, the last thing I need to do is somewhere on my Cartesian plane, I need to write what this function is. So it's y equals negative 2 on x. Now, my domain and range is exactly the same as question 1 because that is where my asymptotes are. So my domain is negative infinity to 0 and 0 to infinity. My range is also negative infinity to 0 and 0 to infinity. So all of the functions, or most of the functions that we have looked at so far, have been smooth, unbroken curves or lines, and they've been continuous functions. Okay, that means that our parabolas, our linear functions, our cubics that we did back in functions, they were all drawn without lifting the pen off the paper. However, some functions like hyperbolas have discontinuities, meaning that their graphs have gaps or breaks, okay, and they're called discontinuous functions. So the hyperbola has discontinuity at x equals 0 for our basic general form of our hyperbola, and this is because there is a gap in the graph at that point and we have 2 separate parts. So that is all about our continuity. Now, I've touched on our asymptotes. Our asymptotes for the hyperbola y equals 1 on x do not touch the x or y axis, but get closer to them. We call the x and y axis our asymptotes, which are lines that the curve approaches but never touches. So we can find the shape of the graph close to the asymptote as x approaches plus or minus infinity by checking points nearby. All right, flip the page for me. We're going to do a little run through about what we've just learned about a parabola. A hyperbola. So a hyperbola is y equals k on x. It has a centre of symmetry at the point 0, 0. Okay, it has rotational symmetry of 180 degrees, meaning you can pick up your piece of paper and rotate it 180 degrees, and that is about our origin 0, 0. It has a discontinuity at x equals 0 and has two separate branches in different quadrants. The horizontal and vertical asymptotes are the x and the y axes, respectively, and then our domain is negative infinity to 0 and 0 to infinity, and our range is negative infinity to 0 and 0 to infinity. Now, if we have k is positive, like we did in example 1, the graph is in the first and the third quadrant. And if k is negative, like we did in the second example, the graph is in our second and our fourth quadrants. So what we have looked at is our general shape of our hyperbola, y equals k on x, but we can transform our hyperbola around our graph, and we're going to see how that happens and how we can sketch one that has been moved. Okay, in this course, you are going to always have an asymptote at y equals 0 for all of them, but you're going to have that your graph is going to move to the left or the right. If you have an asymptote where your graph isn't at y, I'm just checking. No, we just have y equals 0. We will look at some later on next term where we might move them up and down. So, example 3, we're going to find the domain and range of our function 3 over x minus 3 and sketch the graph of the function. Now, the first thing that we need to look at is our denominator can't be 0. So what that means is that our x minus 3 cannot equal 0. So that tells us that x cannot equal 3. Okay, because if we plus our 3 to the other side. This therefore means that we have an asymptote at x equals 3. Okay, so at x equals 3, which is a vertical line, we have an asymptote there. Now, we also have that then tells us our domain. Okay, that helps tell us that our domain is going to be from negative infinity to 3 and 3 to infinity. So wherever our asymptote is, Jaden, that tells us and helps us where our domain is. Does that make sense? Okay, what we also have is that y can't equal 0. So therefore, we have an asymptote at y equals 0. And that then helps us with our range. So therefore, our range is going to be negative infinity to 0 and 0 to infinity. Okay, what we have is something called limiting behaviour, which we touched on when we looked at our polynomials or our cubics. So our limiting behaviour is that k is greater than 0. So there is no negative out the front of our function. In 4, you can see that there's a negative out of our front of our function. So that means that k would be less than 0. Okay, so if k is greater than 0, that means we're in our first and our third quadrants. And what this means is that as x approaches infinity, we have y approaches 0 and is positive, meaning that that is when it's in our first quadrant. Okay, so that line there means we're in our first quadrant. And then we have that as x approaches negative infinity, y also approaches 0, but it is negative. Okay, so what that means is as we get closer to infinity, we're approaching that asymptote of y can't equal 0. Now, that tells us that we're in our third quadrant. Okay, the last thing that we need to find is our y-intercept. So for our y-intercept, we need to let x equal 0. So we'll have y equals 3 over 0 minus 3. And when we put that into our calculator, we get that y equals -1. Now, from here, we've got the important information of our asymptotes that help us with our domain and our range. Okay, we also have our y-intercept, and we have which quadrants our limiting behaviour is in. We just don't have some key points, so we can use our table of values in our calculator. We don't have to write one down to help us with that. So when I substitute in 4, I get the point 43. When I substitute in the point 5, I get the point 2. So 4, 3. At 5, I get 1.5. And that sort of doesn't give me enough information, so I want to see what's happening at our 4.5, and at 4.5, that's when it is 2. Okay, so that's going to give me my general shape of my parabola, and we're putting our arrows either side. All right, we're getting that this is our point 4, 3. What is going on with this pen? Okay, now we want to do our third quadrant. So I'm going to substitute in my point 2. And when I substitute in 2, I get -3. I also know that when I substitute in my point 0, I get my y-intercept of -1. And when I substitute in 1, I get -1.5. Okay, and that's enough information. If I wanted more, I could get some more. But that gives me a general gist of where my curve should be and what it should be going through. Okay, I just need to make sure that I label one of my points. So I'm going to label my point 2 minus 3. And then I must label my y-intercept, which is 0 minus 1. And the only other thing I'm missing from this is my fx equals 3 over x minus 3. Okay, moving on to example 4. We want to now sketch the graph of y equals -1 over 2x plus 4. So what we have is our denominator cannot equal 0. So that whole 2x plus 4 cannot equal 0. So we will have 2x cannot equal -4 because we have -4 to the other side in case somebody isn't seeing that, and then we divide by our 2. So we get that x cannot equal -2, and so that is where our asymptote is at. So our asymptote is at x equals -2. So on our graph straight away, we're going to draw our asymptote on at x equals -2. And that information tells us that our domain is -infinity to -2 and -2 to infinity. Okay, we also have that y cannot equal 0. So y cannot equal 0, so therefore we have another asymptote at y equals 0, so we can draw that in. All right, and we therefore get that our range is -infinity to 0 and 0 to infinity. Okay, like I said, our limiting behaviour is that we have k is less than 0. So our limiting behaviour, we have k is less than 0. So this means we're in our second and our fourth quadrants. Okay, so what we have is as x approaches infinity, we'll have that y approaches 0 and is negative. So that means that our y values are going to be negative. And then we have as x approaches negative infinity, y still approaches 0, but it's positive. So end is positive. So that means we have positive y values. The last thing we need to do for this question is work out our y-intercept. So our y-intercept, we let x equal 0. So we'll have y equals negative 1 on 2 lots of 0 plus 4. So our y-intercept is at negative a quarter. Okay, we have a lot of information to put on our graph, but we also have a bit that we need to find. So we have our y-intercept is at negative a quarter, so we can put that on if we'd like. All right, but then we need to find some key points. So I'm going to start with my quadrant with positive values, positive x values, but I'm going to substitute in negative 1.5. So when I substitute in negative 1.5 for x, I get negative 1. Okay, that is going to give me, if I substitute in negative 1 as well, probably should do that, that gets me negative a half. Okay, that gives me enough information to get the general shape of my curve for the hyperbola in that quadrant. I need to label my y-intercept, and I need to label that a key point. So it was negative 1.5, gives me negative 1. Okay, then in our negative x values, we have at negative 3, it's a half. Let's also see what's happening at negative 2.5. It's at 1. Okay, so then we quickly sketch that curve. We have enough information. We know the shape of what the curve should be, but we have a nice key point. So our key point that we're going to use, I'm going to use the point negative 3 a half. Okay, and that's it. Oh, I'm missing the function. So y equals negative 1 over 2x plus 4.